Welcome back, everybody. Hope you had a great new year. We're going to start off with exponent rules today. You have this on your note sheet. Pause the video, take a few minutes to fill this in. A few key things on here to note is that you have your base, which is a big number, and then your teeny number that's usually in the upper right-hand side is your exponent. Those exponents tell you how many times you multiply the base by itself. So we have 3 squared means we have 2 3s. 3 times 3 is 9. 2 to the 4th means we write 2 4 times. Multiply 2 times 2 times 2 times 2 is 16. X to the third, 3 x's. Non-examples. 3 to the second power does not mean 3 times 2. And the answer is not 6. 2 to the fourth power is not 2 times 4, which is not 8. So we never multiply that base to the exponent. So let's take a look at what we have for some examples. Negative 2 to the fifth power means we're doing negative 2 times negative 2. I'm going to write that 5 times. And then if I type that all in the calculator, or I do that all in my head, we end up with an answer of negative 32. Negative 3 squared, we have negative 3 times negative 3, which is positive 9. I want to be careful of the difference between these two examples because in this middle example we just did, the negative 3 is in a parenthesis versus this last example, the negative is not in the parenthesis with the 3, which basically means we have the negative and then we have that 3 twice. 3 times 3 is 9. And then the negative on the outside makes that a negative 9. Clean that up a little bit. So we have to be careful of where the negative is because the sign of the answer will be different. And we'll talk about how to get these on the calculator in class. Exponent rules themselves. When we're adding and subtracting terms, we don't actually do anything with the exponents. The exponents stay the same, do not change. The only thing that changes are the coefficients in the front. So 3x to the third and 4x to the third, because those are both x to the thirds, we can do 3 plus 4 is 7. Remember, we're just combining like terms at this point. C to the fifth and c to the fifth, we're combining negative 3 minus 7 more is negative 10, c to the fifth. P squared and p squared, 6 minus 12 is negative 6, p squared. So again, if we're adding and subtracting our like terms, our bases, then we don't change our exponents. Multiplication. All of these exponent rules are really just shortcuts. They're helping us not have to write everything out super long. So if we were writing this out, r to the third would mean r 3 times. And then we have times r squared, which is another 2 r's. So how many total r's do we have written there? Well, if we count them up, we have r to the fifth, or 5 r's. So our answer is r to the fifth. So what could we have done with that original 2 and 3 exponents to get to 5 without having to write all that out? Well, we could have added them. So that brings us to our rule that when we are multiplying like terms, we add their exponents. So our bases here are q and q. That means we're going to do 4 plus 6, which is 10. So our answer would be q to the 10th. We have our same bases of w and w. 5 plus 2 is 7. So our answer would be w to the 7th. Be careful with these ones. If there's no exponent there, remember it's an invisible one. So I go ahead and I write those ones there just so I don't forget. We have both of them are base v, so 1 plus 4 is 5. And then all of these are base m, so 2 plus 3 is 5. 5 plus 7 is 12. Exponent over exponent, or power of a power. If we wrote out this expression, f to the 4th squared, we would have f to the 4th twice. Then, according to the last rule that we just made, we would add the 4s, so 4 plus 4 is 8. What could we have done with the original two exponents of 4 and 2 to make 8? Well, we could have multiplied them. So the rule is when you have an exponent of an exponent or a power of a power, you multiply them together. Taking a look at these examples, we have d to the 3rd to the 4th. Those are both exponents next to each other. So 3 times 4 is 12. S to the 5th to the 3rd. 5 times 3 is 15. H to the 7th to the 8th. We have 7 times 8 is 56. And K to the 6th to the 11th. 6 times 11 is 66. The division rule. So if we wrote out t to the 10th and t to the 4th, we would have 10 t's in the numerator and 4 t's in the denominator. Now when we're dividing and we have the same thing on the top and the bottom, we're allowed to reduce it out. So I'm reducing each of these t's. And so what do we have left? Well, we have left this group of t's in the numerator, and if I count them, 1, 2, 3, 4, 5, 6, we have 6 t's left. Well, again, our question to make this easier on ourselves is what could we have done with the original exponents of 10 and 4 to make 6? Well, we could subtract them. So when we're dividing with exponents, we subtract the exponents. These examples, we have b to the 13th divided by b to the 3rd. 13 minus 3 is 10. L to the 6th divided by L to the 3rd. 6 minus 3 is 3. Again, remember, if there's no exponent, there's always an invisible 1. So I would always put a 1 there and say p to the 7th over p to the 1st. 7 minus 1 is 6. This is where we are going to stop for today. Thanks so much for joining me. Have a great evening.